Assalamualaikum and hi everyone. Now you are watching 6.3 Chemical Properties of Benzene Video 3. In previous videos, we already discussed about introduction and nomenclature of benzene and its derivatives. Now, let's continue with 6.3 Chemical Properties of Benzene and its derivatives. As the learning outcomes of the lesson, you should be able to explain the electrophilic aromatic substitution reactions of benzene for nitration, halogenation, FRIEDEL-CRAFTS alkylation, and FRIEDEL-CRAFTS acylation. Chemical properties of benzene. The reactions of benzene involve the benzene ring itself. This is the example of electrophilic aromatic substitution. The reactions of benzene also involves substituents attached to the ring. This is the example for the reaction. Electrophilic aromatic substitution is the characteristic reaction of benzene. A hydrogen atom is replaced by an electrophile as shown in the equation below. Generally, aromatic compound of benzene has four chemical reactions. The figure shows the reagent and condition and also the product form for the electrophilic aromatic substitution. 1. Nitration. 2. Halogenation. 3. FRIEDEL-CRAFTS alkylation. And 4. FRIEDEL-CRAFTS acylation. Let's rediscuss one by one for all the reactions. Nitration. Benzene reacts with concentrated nitric acid at temperature 50 to 55 degrees Celsius in the presence of concentrated sulfuric acid to form nitrobenzene. Here's the equation for the nitration of benzene. A nitronium ion add to the benzene ring in a place of this proton form nitrobenzene and side product H2O. Halogenation. Benzene reacts with halogen in the presence of Lewis acid like FeCl3 and FeBr3 to form aryl halides. For the first reaction, benzene does not react with bromine without Lewis acid catalyst. Lewis acid is very important for the halogenation reaction. The second reaction is occur in the presence of catalyst. A bromonium ion add to the benzene ring in a place of this proton form bromobenzene and side product HBr. Function of Lewis acids. Lewis acid acts as catalyst to increase polarity of halogen molecules and produce positive halogen ions, either bromonium ion or chloronium ion. Example of Lewis acids are FeCl3 and FeBr3. FRIEDEL-CRAFTS alkylation. Benzene reacts with alkyl halides in the presence of aluminium chloride AlCl3 to yield alkyl benzene. Alkylation is a process transfer an alkyl group to benzene. Here's the general equation for the reaction. An alkylium ion add to the benzene ring in a place of this proton form alkyl benzene and side product HX. First example, the reaction of benzene with 2-chloropropene in the presence of Lewis acid AlCl3 produced isopropylbenzene and side product HCl. Second example, the reaction of benzene with 2-chloro-2-methylpropene in the presence of Lewis acid AlCl3 produced third-butylbenzene and side product HCl. Other facts about Friedel-Crafts alkylation. Rearrangement can occur, especially when primary haloalkanes are used. For example, the reaction of benzene with chlorobutane in the presence of ALCl3 produced butylbenzene with the composition 35% and sec-butylbenzene with the composition 65%. This is the result from the rearrangement of primary carbocation to a secondary carbocation. Secondary carbocation is more stable than primary carbocation. Friedel-Crafts acylation. Benzene reacts with acyl chloride in the presence of Lewis acid catalyst ALCl3 to yield benzophenone. Acylation is a process transfer an acyl group to benzene. For example, from this reaction, an acylium ion adds to the benzene ring in a place of this proton form acetophenone and side product ACL. Acyl group. An acyl group can replace hydrogen in an aromatic ring by a reaction Friedel-Crafts acylation. An acyl group is a group of atoms consisting of a carbonyl group bonded to the carbon group. When R is a CH3 group named as acetyl group, and when R is a benzene ring would be named as benzoyl group. Thank you for watching.